Good afternoon, everybody. Welcome to today's webinar. The theme of the presentation today is supporting DevOps through testing, and it's subtitled, "It's not just about automating tests." I'm absolutely delighted to announce the presenter today and introduce him. Our presenter is Danny Crone. Danny is a test practitioner and also a technical director at the award-winning testing consultancy NFocus. In fact, I've had the pleasure of listening to Danny's presentations at conferences a number of times, and I can assure you it's going to be a really good webinar today. Also, just to let you know that today's webinar is in association with our conferences taking place on the 11th of February in Manchester. We're holding Testing Showcase North and also DevOps Showcase North. They're co-located. If you'd like more information on those, they'll be available at unicom.co.uk. After the presentation today, there's going to be opportunity for questions, so please have your questions ready and feel free to type them in the box on your screen, and we'll assign those to Danny, and he'll do his best, hopefully, to answer them in the time. So without further ado, I'm going to hand over to Danny.
Thank you very much, Alec. Appreciate that. Good afternoon, everybody. I just wanted to start with the first of all the aims of DevOps. It's certainly a culture and a practice that accentuates the collaboration and communication of both software developers and other IT professionals, while still being important to automate the process of software delivery and infrastructural changes. It certainly tries to foster both a culture and an environment where building, testing, and releasing software can happen rapidly, frequently, and more reliably. So the question here is, wouldn't just speeding up the testing, automating it, actually help? Well, we're going to take a look at how testing can help DevOps, automated testing, and first we're going to take a look at the challenges of DevOps, the release pipeline, what tests we should think about automating, how best to consider test data for environments, and finally, we're going to take a look at the pipeline and how we feed back information. Integrating DevOps should target product delivery, quality testing, and development so as to improve reliability and stability and provide faster development and deployment cycles. So development wants stuff faster, they want releases faster, and operations want stability and reliability. Now, if manual testing can help improve the stability and reliability of a solution or an application, but generally takes a long time to provide decent levels of quality, then wouldn't just automating all of that testing effort solve all of your problems? The main questions we should ask ourselves in this situation is, what's the coverage of those test cases? How long do they take to execute, and in which environments do they need to run? How are they going to be coordinated, and how successful are they? So let's take a little look at the release pipeline to see where the tests actually need to be performed. Now, this is not typical of every situation, but there's often different environments and many different environments. Each of them potentially are different in terms of infrastructure, size, configuration, and connectivity to other systems. We can see here a system testing environment, and that might be a single server with all aspects of the application being installed on a single machine or instance. And, of course, connectivity to third-party systems might very well be, or should in theory, be stubbed at that point. Whereas system integration testing might start to get a little bit more production-like. There might be a number of machines, and we might be splitting the roles of the application onto the different machines. Now, this might have connectivity to third-party systems, and it might be the test versions of those systems. Pre-prod, as we get further down, might be very close to production, and the third-party systems that it's using will again be test versions, but might be different to the ones that we were allowed to use during system integration, the scaled versions effectively. Now we're not, and this would allow us to do certain types of testing like performance testing, but we're not going to focus too much on performance testing in this session. However, it is fair to note that the wide variety within the different environments. Now let's move on to automated testing, but later we're going to revisit this to overlay testing and automated testing onto these pipelines. First of all, the importance of automated testing, and more importantly, the importance of automated testing over manual testing in this context. Of course, it's an important activity to ship high-quality software, but the benefits are the fact that we get these early quality indicators. Automated tests that run after every build of the source code provide early feedback of possible quality issues in the product. As an example, if a test fails that has historically executed successfully, we might be noticing a regression caused by some kind of code change. Finding out about these potential defects in the existing functionality quickly is paramount to keep the quality of the product high and reduce the cost of fixing the problems. Get into the market quicker by automating routine and mundane tasks such as manual regression tests. A team can ship software sooner and achieve or maintain competitive advantage through increased efficiencies. Tests that execute in minutes may take a human being an order of magnitude more to execute. Additionally, automated tests aren't prone to human error and execute the same way every time they're run. There is a caveat here, though. Automated tests may not indicate other types of issues, such as improperly rendered charts, or and also the fact that some or there may be much redundant automation, and that can have a negative impact on progress. So you can write them once and run them everywhere. Automated tests run many times over and with different combinations. And this is good for moving tests through different environments, but also for other situations like combinations of web browsers and operating systems to give your test coverage of your test matrix. Accurate validation, and again there is a little sort of caveat to this, but a test might be easy to execute or automate, but validating the results of a test may be time consuming. Consider something like an accounting system, and you've got some complex calculations going on in a spreadsheet, and it produces a big spreadsheet of results. A human being is going to take a long time to validate some results in a sea of numbers, but an automated validation can take a fraction of a second. The caveat here is that, of course, sometimes if the robot's not told to look for something, it won't. So you know, it's not all blue skies here. Difficult scenarios, and this sort of moves on to sort of non-functional aspects. So attempting to validate the scalability of a SaaS product without automation is going to be really difficult. How do you simulate thousands of users? Cleaning the architecture, building test automation, and thinking, more importantly, test first, helps produce a clean software architecture. By building in testability into the design such that automated tests can call the right APIs to execute positive and negative paths alike, the architecture is inherently going to be more decoupled with cleaner interfaces than if the API level tests were never considered. And coverage is another thing, and this mostly relates to unit tests, but can relate to functional tests as well. Being able to spot the gaps. Running automated tests at a regular cadence helps indicate how much of the code or the product code is tested. Without automation in place, it's going to be difficult to obtain that data easily. Regular test automation runs compute code coverage and provide feedback on that via a number of different tools on where additional tests may be needed, and the coverage percentage should increase over time. providing more confidence and reducing the amount of regressions. So this is some of the reasons why automated testing is going to be useful to a pipeline. But the question is, what do we put into that? So what is it that we actually automate? Does it make sense to automate all of the tests? I think the answer to that is typically no. I don't think I've ever been in a situation. I think about 88% was about the closest that I got to full automation, but typically no is the answer. And typically in scenarios where there's continual enhancements to legacy applications that have always been tested manually through its history, these applications typically weren't designed with testability in mind, and it would be difficult to retrofit any kind of automation on top of it. I get that a lot from developers. You know, we just can't do unit testing. It's not designed for unit testing. But with the exception, however, of UI automation, additionally, the investment in automation for stable areas of the application may not be warranted. So for green site or green field applications, however, it can be designed for testability, and teams should automate a higher percentage of tests, but there's still room for manual verification, and it should be mandatory to do exploratory testing. Assuming the decision is made not to automate everything, what should we be automating, and what test cases should we automate first? A useful input for making those decisions is the existing set of test cases that have historically been run manually. It may be a large list, however, so we need to prioritize, and the question is, how do we prioritize it? And what we tend to do is put things into buckets, and we notify them as P0 through to P3, but essentially they fall into these categories. Smoke tests, this is a small number of tests, and they're run regularly, preferably after each build of the software. They validate the most basic and important functionality of the system. Does the application launch? Can a basic user log in? Can the primary use case be initiated? The number of test cases here are typically really small and much smaller than the other buckets, but they're the ones that are almost always automated, and they're the ones that are run the most. BVTs go a level deeper certainly than smoke tests, and they cover the most important use cases of the application or software. They're generally executed daily or after a nightly build, ideally in an automated fashion. We always try to automate these, and we always try to get some of these into a CI build, but we'll come on to CI a little bit later. Functional tests, now this is the biggest bucket really, and they're executed whenever a regression test pass is required, such as at the end of an iteration or release. This bucket contains the most tests and exercises the majority of the user interaction with the software. Not all of the tests in the P2 bucket are going to be automated, so we need a little bit more to help us with how we choose which ones to automate. And the low severity ones, well, this bucket reflects things such as boundary case, or areas of the application that are less frequently touched by either the end user or the developer. They're generally not automated, and they're executed less frequently than the other buckets. So given those priority definitions, automating P0 and P1 test cases is highly recommended. However, deciding how to assign test cases to the various buckets, as well as what to automate in specifically the P2 and P3 buckets, requires a few more guidelines, and that's why I put this table up. I'm not going to go through it in detail, and I know the slides are going to be available for download later, so you'll have this to look through a little bit later. The bottom line is, will automating a test provide a return on investment of creating it? If the effort involved in creating and maintaining the test case is larger than the efficiency gains projected over the life of the test case, then don't automate it. Prioritize the test cases accordingly and start by automating P0 and P1 buckets. But they also, even though we're going to automate them, they have to be reliable, and it's important for them to be reliable. And these are some of the reasons. Test failures are often a combination of legitimate issues that the tests are designed to find or identify, but also the noise that's generated by unreliable tests. The noise can become overwhelming, and I've certainly been to lots of organizations where, you know, they show me the pack of 200 test cases that don't run, you know, and it's really becoming a bigger and bigger problem. Every time a test fails, they move it into this bucket. So the noise can become overwhelming, and it impacts our ability to make decisions based on the test results. But more seriously, it undermines the trust that we have in our solution and the regression test pack. Test reliability is such an important and visible measure that we need to review it and call it out at every sprint review to analyze and drive test improvements. I'll talk a little bit more about that later, but when test reliability, and it's not to be mistaken with test success, is near 100%, then we have a high degree of confidence that test failures are real failures. They are likely to be bugs. So we've got to set ourselves some goals to empower us to ship frequently and with confidence, friction-free, that the system supports automated testing, and we get updates within 15 minutes of a check-in, and that sort of ties into the CI stuff that we'll cover in a bit. Fast and reliable tests. These allow us to test and react to test failures quickly. And of course, automated tests save time. They increase accuracy, coverage, and perform what manual testing cannot. That doesn't mean to say we don't do manual testing. It's just that we need to we need to balance that somehow. So what I put together here is some test principles, and these enable us to transform to a reliable and automated test classification. I'm not going to go through this in too much detail, but suffice it to say that we should design for testability from the start, and it shouldn't be an afterthought. Tests should have a predictable outcome, and I say no dependencies, but little dependencies. In some cases, it's almost impossible to get away from some of those dependencies. They should be easy to author and understand, and let's not forget that test code is just code too, and the same rules that apply to the application code, we should be applying to our test code, and it should be stored together in the same repository with the development code. Try to avoid using backdoors. Use only publicly available APIs. This means that you increase your coverage as well, but that you're not finding a problem because of the way that you actually injected some data. Target lower level tests. This is really around unit tests, and make sure that you've got fewer external dependencies. So unit tests with little dependencies are going to be an area where you're going to get a lot of value out of. And finally, in terms of the noise, reduce the noise by quarantining unreliable tests. Don't quarantine them, you know, infinitely, and for that quarantine pile to just build up and build up over time, because that still undermines trust in the automated tests. Fix them or retire them for good. The last aspect that I want to look at in terms of automated tests is the test data. And successful approaches to test automation relies on repeatable test data. For the automation suite to run successfully, it requires assumptions to be made about the data available. For example, does the data change? Does it expire? Does it get stale? Is there different static data in different environments? Different URLs to get to various different places and so on. There's a number of strategies that people use to manage automated test data, each with their own advantages and disadvantages. A key point though is that data for tests is either configuration data, input data, or expected data. Assuming that data needs to go across different test environments, then it's always safer to store that data inside files and have the test read from these files. That allows the same test to run in the different environments with different configuration data for its purposes. In this section, I'm going to highlight some of the popular approaches, some of the ones that we've used in the past. First of all, production copy. It's a full copy of the production data used for the automation purposes. This copy is periodically refreshed. Now, there's some good and some bad here. The good is that it provides us with the real shape of production. The data itself represents real life. It's generally easy to set up. It's usually just a restore from a backup of production. However, on the downside, the data may contain identifiable information, and that might breach privacy and data protection laws. So, as such, the data needs to be masked or cleansed in order to hide that sensitive information. The data, of course, might be very large and take up a lot of resources. Copying a big backup file across the network might take a long time. Restoring it might take a long time. Cleansing it might take a long time. Even if only a subset of production data is taken, it can still be difficult to build a subset that maintains referential integrity and still contains no sensitive data. Tests that populate their required data. This puts the responsibility on the test or a suite to insert its data it needs before the test is run. After the test or suite is finished, the data is removed. This is good because the tests are self-describing, including all of the required data. Data schema changes may reflect directly on the tests, and that would be good to know about the fact that the schema is changing. However, it may become very complex to insert some types of data, and some types of data might need to be aged for a particular test, and that might not be possible. It certainly requires that test authors understand how to create the data they need, and sometimes that might be beyond certain types of testers. The next one we've used quite a bit over the years is that the tests select their required data as part of the run. They don't inject it as such. They go look for it. So each test performs a search on the data set before it starts to execute for what it really needs. For example, a customer that's got a foreign currency account with a balance greater than £50,000. If the search for that data fails, then the test fails. Again, great because it's self-describing and it includes all of the required data. The tests don't assume that specific data records are present. However, on the downside, it can be destructive to the data. So if a test closes an open account, then it might quickly exhaust available records for other tests, which causes failures. Certain types of data could require very complex queries, and I know I've got into that situation quite a few times. Transaction reset, and there's some good opportunity for one, and also some places where it doesn't really work. So a baseline data set containing all the data is located. Each test is performed as a transaction that's rolled back upon completion, leaving the data unchanged. There's a one-time setup of the data, and it can be reused many times. And the test author doesn't really need to understand the data structures. Again, it's kind of like a backup and restore. But there are transactional limitations. As we move to distributed systems where you may be calling out to third parties and we may not have control over those, and in fact all of that distributed data can't enlist in a single transaction that can be rolled back. So so there are challenges there. And again, schema changes might need to be introduced into the baseline version as they're developed. So there's quite a few, well, there's a few different approaches there, but the question is, how do you choose the right one? And remembering that, of course, each environment that's moved through might contain different machines, infrastructure. For example, here the system testing environment might have the external system stubbed. The system integration environment may be hooking up to third-party systems of which you have little control. So an approach where it works in one environment might not work in others. And remembering that we're trying to reduce friction here, it's really important to consider the other environments. We don't want to hit an environment and say we can't run our test automation here for these reasons. So the suggestion is to take a limited amount of tests and try and automate them in one environment using some of the approaches to test data that I've laid out. Move it through the other environments and change it as required, remembering that, of course, you need to retrofit those changes to the previous environments that you've already visited just to sanity check that it still works in those environments. So now we've looked at what to automate and how to get those reliable with test data in different environments. Let's just take a look at the deployment pipeline now, and let's look at the first steps. And I consider the first steps to be continuous integration. I think this is where the journey starts. So in order to get continuous deployment moving, it's got to start with CI. And CI builds with unit tests allow us to respond to failures quickly and ensure all development parts are well integrated. Every time a developer checks in a code or commits into the source control, then a build is triggered. The build is responsible for compiling not only the application code but also the test code to run the unit tests and other tests here as well potentially. Package that build and update the results back to the developer or any other dashboards, and preferably if this is in an integrated ALM tool such as Visual Studio's Team Service or TFS, then that's the sort of nirvana really. It is possible to integrate functional tests into the build. Although this often requires on the build agent an interactive user and possibly a local deployment of the system to be incorporated into the build process. So that the process that's running over here, compiling, running unit tests and updating the results, that needs to take into consideration the other things that are required in terms of executing those above the glass UI type tests. We always strive to get functional tests into the CI build, although we do limit that to the smoke test, possibly with the BVT, depending on how big the BVT is, so that automated tests can be friction-free. But in order to achieve this, that build still must complete within around 15 minutes. Now, there's tooling here. And which tools depends on which type of applications are being produced and which technologies, but often we see CI tools like Cruise Control, Jenkins, or Team Foundation Server, compilers like Ant or MS Build, and testing tools like NUnit, MS Test, and JUnit. So there's some tools that need to be learnt or understood. Generally, they're not that complicated. People think they're more than what they really are. So what's the next steps? Is moving on to continuous deployment. And the process of automating software delivery is crucial. So tooling and a workflow to manage the pipeline is required to enable this. And I know that DevOps is wider than just the automation of, but it is a crucial part of it. So tools such as Microsoft's Release Manager, Chef, Puppet, Jenkins all come into play to handle such activities as provisioning environments, deploying applications to environments, and running tests. But they all have different levels of functionality, and some go further than the others. But the most important aspect is how the pipeline is orchestrated, the workflow, in terms of decisions to move from one environment to another. So, you know, when you're here making this decision on to go into the next environment or break out, how do we make that decision? How is that decision given to people? It's important that stakeholders should be notified when they're required to authorize the movement from one environment to the next. And certainly in order for those individuals to make a decision, or for that decision to be automated, then the information needs to be available to make the decision. This is predominantly where automated tests serve that purpose. The testers need to therefore ensure that the automated tests report their results in a form that's easy to consume, and often this requires scripting. And so testers need to get involved in scripting at these points: provision, deploy, and test. So provision would really be, okay, do I need a test agent? Do I need multiple test agents here? So I want a Windows Server machine that I can run my tests on. Deploy is, how do I deploy the test assets? What's the pack of tests that I'm actually going to pass down, and what data goes along with it? And here, how do I orchestrate the execution of that pack of tests and feedback the results, so that we've got our information to be able to know whether to proceed or not. That's a lot of you know, within the tools, that can be a lot of scripting. It can be PowerShell scripting, or it can be batch file processing, but it requires the tester to get involved in helping out with that. So just as we come to a close, what I'm going to do is just try and conclude a few things and say that it's not just about automating tests. I know we talked about automated tests a lot there, but the devil is in the detail. It's about automating the tests in such a way that they're robust, reliable, and friction-free. Test data in different environments needs to be well thought out and considered in order that those tests can be reused across different environments. And automated tests need to be dovetailed into the pipeline, and that requires different skills for testers. We need to be able to clearly present the information about execution to enable stakeholders or the automated system itself to make decisions. So, finally, a little plug. Here at NFocus, we're one of the longest established and trusted consultancies in the UK. We've got deep expertise in test automation, and provide things like test automation health checks to help you understand your current state and provide a roadmap for future improvements. If you want any more information, please contact me on any of these means below, either my email address dan.crone@nfocus.co.uk, or you can catch us on Twitter at nfocus_limited. I'd like to open up for any questions.
Thank you very much, Danny. While we're waiting for questions, just again to say thank you very much for excellent presentation this afternoon, and remind you that we will be making a recording available, so if you'd like to share it with your colleagues or see this and watch the presentation again, you'll be able to do that. We'll send a link shortly for that to everybody who's attended today. And also just a reminder that you can actually meet the guys from NFocus in person on the 11th of February in Manchester at Testing Showcase North and DevOps Showcase North. The website for those is unicom.co.uk. I'm just waiting to see, Danny, if there are any questions coming in. We haven't got anything as yet. Perhaps just give it a few more seconds. And so it doesn't seem to be any questions today. So all I can say is thank you very much, and we hope to see you in February. Thank you.
Yes, look forward to it. Thank you very much, and have a great day, everybody. Thank you for your time.
Thanks, everyone. Bye.